Welcome to a video on JSON and its usage in decisions. In this video, we will look at the following topics. What is JSON? The need of JSON, use cases of JSON, its structure, data types, how to create decisions data structures using JSON and JSON schema, steps in decisions for JSON, serialization and deserialization, and when to use JSON schema in decisions. What is JSON? JSON stands for JavaScript Object Notation. It is a text-based format used to store and exchange data between a web application and a server. It is a human-readable and a machine-parsable text format. It is represented as key-value pairs. An empty JSON can be represented with an empty curly braces. Please note that JSON is not a programming language and is strictly a data format for exchanging information between different systems. Why is JSON widely used over other text formats? Most modern programming languages provide built-in libraries or functions for parsing JSON. It is supported by a broad array of technologies, making it a standard choice for data interchange over the network. Now let us see a few use cases of JSON. 1. Data exchange. It is used for data exchange between client and server architecture. For example, web APIs. 2. Configuration files. It is also used for configuration files as it is easy to read and edit manually. The examples are AWS Cloud Formation Templates and Google Cloud Deployment Manager. 3. Data storage, especially in NoSQL databases like MongoDB. 4. Real-time data streams like chat services, live notifications, stock price updates, etc. Now let us see how is JSON used in decisions. Decisions as a client. Let us consider a scenario where Oliver, a decisions developer, is using an application to fetch weather data from a weather API. So as you see in the diagram, the decisions server here acts as a client and sends a request to the URL of the weather API server. It receives information in the format of JSON. Decisions as a server. Let's consider a scenario where Hazel, a decisions developer, has developed an application that sends a JSON response to the client system. Here, as you see in the diagram, the client system is accessing a URL that is hosted on the decisions server, which sends a response in the format of JSON to the client system. Structure of JSON. It is a collection of data items separated by commas and enclosed in curly braces. Each data item is represented as a key value pair separated by a colon. Structure of JSON. The key must be of string type and the values can be one of the following types: string, number, object, boolean, array, or null. The last data item in JSON should not have any trailing commas. Data types in JSON. String. A collection of characters enclosed in double quotes can be considered as a string in JSON. Please note that single-quoted strings are not valid here. For example, here we have John, which is a string associated with the key name. Number can be of any format like integer, floating type, decimal, double, etc. Here, 28 is a number associated with the key age. Boolean can be of two values, true or false. In this example, is employed is a key that is associated with the value true of Boolean type. Array. Collection of items enclosed within a square bracket can be considered of type array. Here, JavaScript, Python, SQL, enclosed in the square brackets, is of array type associated with the key skills. Object. It is a JSON, a collection of data items within curly braces. Here, the data items street, city, and zip enclosed within the curly braces form an object, which is associated with the key address. Null indicates the absence of a value. In this example, hobbies is associated with null. Please note that null is not same as 0. Now let's see how to create decisions data structures using JSON. There are two ways in which we can create that. One is to create types from JSON, and two, create types from JSON schema, as shown in the image on the right. Let us now see a demonstration of creating types from JSON. For this demonstration, I have created a REST API through which I will receive a JSON response. For example, here I have a method called validate insurance provider, and upon testing this method, I would receive a response. Give the provider name as claims are us and execute the test. As you can see here, the response is received in a string format. To receive this response in a JSON format, we can go to the data structures and create a type from JSON. So click on Create Data Types or Integration, navigate to XML JSON CSV category and select Create Types from JSON. For the JSON structure name, I can give insurance provider name. I'll keep the namespace as such for now. Allow nullable values will allow null values for all the properties of a JSON. Use JSON file to choose a file from the local system. Uncheck JSON file to paste your structure here. I have a JSON structure that I will paste here. As you see, the decisions environment prompts us to create steps for this JSON structure. Check this box and click on Create. Please note that the steps to be generated is completely optional. Now, we see a JSON structure and a simple flow structure that is associated with it. To use the steps that are generated, let us create a flow. Call this as validate insurance provider flow. I will pick the REST method from the integration. Give the provider name as claims are us and debug this flow. We see that the data is received in a string format. Since JSON is a user-defined type, we would find the JSON steps under user-defined types. So scroll all the way down in the toolbox to user-defined types. And here you will find two structures related to JSON, JSON structures and JSON schema structures. Since we have created a JSON structure now, expand JSON structure to see the steps, serialize insurance provider name and deserialize insurance provider name. We will talk about these steps in the upcoming slides. Before we proceed to create types from JSON schema, we should first understand what a JSON schema is. JSON schema is like a formula which can be substituted with values later on. To create a basic schema definition, define the following keywords. Schema specifies which draft of the JSON schema standard the schema adheres to. Title and description state the intent of the schema. These keywords don't add any constraints to the data being validated. Type defines the first constraint on the JSON data. In the product catalog example below, this keyword specifies that the data must be a JSON object. Properties. In JSON schema terms, properties is a validation key. When you define properties, you create an object where each property represents a key in the JSON data that is being validated. Here, full name is a property of type object, and age is another property of type integer. Required. This is used to specify that certain properties are required. In this example, both the properties full name and age are required. Let's see another example of JSON schema and how the JSON instances can be validated. Here is a JSON schema of a product that has two properties, product ID and product name. The two constraints here are product ID should be of type integer and product name should be of type string. Also, these properties are required. Now let's take a JSON instance. This is a valid JSON instance because the values of the data items are of the types given in the schema. Here is another JSON instance, which is an invalid one, as it does not adhere to the constraints that are provided in the JSON schema. Here, A2 is the value for the property product ID, which is not of an integer type, making this instance an invalid one. Now let us see a demonstration of creating types from JSON schema. I will use the same REST API example for creating types from the JSON schema. Go to the data structures, click on Create Data Types or Integration. Navigate to XML JSON CSV category where you will find Create Types from JSON schema. Click on this. For the JSON schema name, I would give insurance provider name schema to indicate that this structure is created from JSON schema. I will keep the namespace as such for now. Check on Use JSON schema file to choose a file from your local system. Uncheck this to paste your JSON schema here. I am pasting a JSON schema here that matches the response received through the REST API. Decisions environment by default generates the steps for this JSON schema, unlike the JSON structure where it is completely optional. Click on Create for the data structure to be created. As you see here, this JSON schema structure is also associated with a simple flow structure. Let us now look at the steps that are generated for this JSON schema data structure. Go to the flow, scroll all the way down to the user-defined types, and now expand JSON schema structures. To find the steps, serialize insurance provider name schema and deserialize insurance provider name schema. We will learn more about these steps in the upcoming slides. We have seen two ways in which a JSON response can be received. To process this data further, we should understand the concept of serialization and deserialization. Serialization. The process of converting an object into a JSON formatted string that can be easily saved, transmitted, or transferred between systems can be termed as serialization. Before serialization, the JSON data looks like this, whereas after serialization, it is converted into a string format. Deserialization. It is the process of converting a JSON string back into an object for processing the information received. Before deserialization, the data is in the form of a string which bounces back to its original structure after deserialization. Now let us see serialization and deserialization in action with the JSON steps that we have generated. Now we are aware that this REST API method would give the response in the form of a string. Therefore, to convert this string into a JSON format, we use the process of deserializing the data. So here I would be using the deserialize insurance provider step and place it in the flow. Configure the properties, and the string to deserialize would be the response that is received from the REST API method, which is result in this case. Save and debug the flow. As you see here, the response that was received in the string format is now deserialized into a JSON object. Let me also demonstrate the concept of serialization, which is converting a JSON object into a string. For that, I take this serialize step and place it in the flow after the deserialize step, as the data that is required here should be in the deserialized format. So I configure the object to serialize as the output of the deserialized step. Save the flow and debug it. Now let's look at the input-output of the JSON serialized step. So you would see that an object is now converted into a string format. The serialized and deserialized formats of this data are not stored anywhere in the decisions environment. It is simply associated to the flow structure that was created. To demonstrate that, let me take a create data step and put it in the flow. I will attach this create data step to the deserialized format as we need the data in an object format. So now create a variable, say insurance provider struct of the flow structure type. Now in the input section, choose the build data mapping option to see the data members. Carefully map each of the data member to its correct value. To store this data in the database, we would require a database structure. So let me go ahead and create a database structure that has the same data members as that of the simple flow structure. So click on create data types or integration and choose this database structure. I would name this as insurance provider DB structure. So now as you see here, the data members of this DB structure are the same as the data members in a flow structure. Click on save to create this structure. Now use the create step of this database structure to create a record in the backend. So build data on it, and now I would map these data members with the data of the flow structure. Please note that the flow structure here is insurance provider struct. Once all the data is mapped, save the flow and debug. Now you would see that an entity ID is generated indicating that a record is stored in the database. Let us now see how to troubleshoot a scenario where the JSON data structure is not available in the flow designer. After the formation of the JSON data structures, to ensure that it is available in the flow designer, go to System, Administration, System Tools, Event Viewer, and fetch the data structure status. Search for the insurance provider data structure and verify that the state is loaded. In case the state is not loaded, go back to the project, click on the three dots of data structures, go to compile and recompile data structures. Post this, your JSON data structures will be available in the Flow Designer for use. Now let us see a demonstration of what happens when the JSON response does not match the given JSON schema. Through this demonstration, we will see three scenarios of mismatched data. Let's dive in. The first method is when a property is missing. So I would remove the property states in network and save the schema. Go back to the flow, use the JSON deserialize step and debug the flow. You will see here that the states in network data is not captured as the property is not available in the JSON schema, though it is received in the response. The second method is when I have a completely different property. For example, I will create a property status 2 of string type. Save the schema, go back to the flow, and debug the flow. You will see that since the status2 data is not received in the response, we have null here for the property status2. The third scenario is where I change the data type of a certain property. For example, here I am changing the data type of the property status to number instead of string. Save the schema, navigate to the flow, and debug it. As you see, this time it is taking the error outcome path. The error message says it could not convert string to decimal. The property status is receiving a string type, whereas the constraint or the JSON schema says it needs to be of a decimal type. In such scenarios, the JSON response is not accepted, which will lead to an error path. Let us now see the format of a JSON response received in decisions.
To demonstrate that, I picked an API that sends the data in the form of a JSON. The JSON thus received has the following properties: full name and age. Please note that any data that is received to demonstrate that I in decisions is always enclosed within the property called done. In decisions,